Hello and welcome back to KXAM Plus. I'm your host, Esmeralda Zamora, and we have our Kristen's Classroom segment with our meteorologist, Kristen Currie, to talk about what everyone saw last night, the Northern Lights, right, Kristen?
Yeah, there were so many of us here in Central Texas that, was in the right spot at the right time, looking in the right direction to be able to see those Northern Lights that we had late last night.
And they looked beautiful. I'm going to share a few of those photos that our viewers sent in to us. Look at that. It looks like
Gorgeous.
the real Northern Lights. It's a little more pink than like green and purplish that we are used to, but I think it's gorgeous.
Yeah, absolutely. I mean, we saw some coming in from the Hill Country, from the Austin Metro, Eastern counties.
Elgin, too.
Yeah. So I would say, there was the opportunity across almost all of Central Texas. The problem is, with these kind of events, we don't get a whole lot of a forecasting time ahead of the event. So I know it's a disappointment when you miss it, but hopefully you were able to get outside just after sunset into the evening hours and catch a view of that. If not, we do have a gallery online at kxan.com. So you can take a peek at what it looks like, over like Buchanan and like you said, over the Austin Metro. It's been a very eventful night with the lights dancing in the sky.
Yeah, but one of the biggest questions that everyone has about this occurrence here in Central Texas is why are we seeing them so close to us, and how do we see these lights? How are they created?
Absolutely. This is the perfect time to dig into a little bit of space weather, if you will. When it comes to the weather we see where we live, rain, snow, clouds, all of that happens in the very bottom layer of the atmosphere. But our atmosphere extends miles and miles up. And so this is, at the very top of the atmosphere that we're talking about. So I'm going to dive in a little bit when it comes to why we see Northern Lights in general here on Earth and why it was so pronounced here in Central Texas. So just kind of bear with me here because I know, it's it's a lot of kind of in the weeds, if you will. But how does an aurora form? Well, think about our planet. We've got our magnetic field around us. The sun puts out these flares or these ejections of electrically charged particles. So electrons, protons, all of that. Think of it as a big plume of charged particles moving towards Earth at millions of miles per hour. I mean, these things are being ejected super fast, speed of light towards Earth. Luckily, our magnetic field actually redirects all of those electric particles around the bulk of the Earth into the poles. It kind of curves around there. And when those particles are redirected at the poles and they start to interject into our atmosphere, they start to collide with the gas molecules in our atmosphere. Nitrogen, oxygen, hydrogen. I mean, we've got all sorts of gases in our atmosphere from top to bottom. So when those electrically charged particles that are being redirected around the magnetic field and into the atmosphere at the poles are colliding with the gases in our atmosphere, and those collisions, depending on what height they are above the surface and the type of gas that electron is colliding with, can sometimes give us these colors. So let's take, for example, oxygen, an oxygen molecule that's colliding, or it's really the electron that's colliding with the oxygen molecule at about 120 miles up, gives us more of that red color. The blue auroras would be a nitrogen molecule in the collision with the electron, and that would be about 60 to 120 miles above the surface. Green would be oxygen, 60 to 20, and then the pink auroras, a little closer to the surface. Below 60 miles, that would be that nitrogen gas molecule. So a little bit of chemistry, a little bit of space science here, but basically you're looking at all of these charged particles coming down, being redirected at our poles, colliding with gas molecules in our atmosphere and giving us those colors. And sometimes it can be kind of like ribbons, if you will, looking like ribbons and following almost a wind-like appearance sometimes, especially early in the morning. You can get a little bit of a cloud-like appearance where it's more of just a color of haze, a hue in the sky, and less of the ribbons. These are very common, obviously, closer to the poles where you're seeing the most amount of those collisions right there. So that would be north of Iceland, Alaska, Arctic Circle north in those very
Where it's very, very cold.
Yes, very cold. But the high latitudes, right? As you get closer to the equator in the lower latitudes, it's much harder for us to see that, but not impossible. Those big plumes of electrons that come our way are called, when they interfere with Earth, a geomagnetic storm. And there's different strengths of these storms. The severity index we use starts at G1, which would be minor. A G5 severe storm would be extreme. The more extreme this geomagnetic storm, the more extreme that this huge ejection of electrons and electrons and protons, these electrical charges, the more likely it can stretch a little closer to the equator. So last night, we had a G4 severe storm. That's one down from the most extreme. So that's why we were able to see the northern lights so far south at such low latitudes. It's because we had such an extreme geomagnetic event. So much of those particles that were being flung from the sun to the earth, being bent around our magnetic field towards the poles, and there were enough to be able to be visible from, not only Texas, but I saw some out visibility pictures from Florida too. So we weren't alone. There was a good chunk of the United States that got to see this aurora from this geomagnetic storm.
And you were talking, when you were saying that our storm last night was just one under the most or the strongest storm, does that come with any risks to us? Like I was reading something about telephone signals and stuff like that.
Absolutely.
What kind of risk is that?
So there's definitely a downside to this. The aurora is the plus, the beautiful lights dancing in the sky. And the downside of this huge kind of surge and collisions of the excited particles and the gas molecules would be sometimes we can see some interference with like our power operation. So you could see some interference or disruptions with the grid system. You can see disruptions in GPS, anything satellite related. You could see some like satellite radio, sometimes even, AM, FM radios you can sometimes see. And I know it's tough to tell on this graphic. It kind of lists them out down there. In an extreme situation here, you would see widespread voltage control problems and protective system problems can occur. Some grid systems may experience complete collapse or blackout. So that would be the extreme situation. Now, it's more common that we see G1s, G2s, which means sometimes you can potentially see some issues, some fluctuations occur with the power grid. Last night, it's interesting because we had a G4 storm. I have not seen any confirmed disruptions with the power grid. Certainly not here in Texas. It's a little more likely as it gets stronger further towards the north, but it is possible that the grid system, sometimes cell signal, any sort of that kind of technology could be affected in a geomagnetic storm of a G4, G5 intensity.
And for places like Iceland that you mentioned, sees northern lights pretty regularly. Do they see the effects of these storms a lot of times?
There's no reason they wouldn't, but there's not a great population up there either. They don't have these giant infrastructure power grids up in the remote areas of Alaska like we do down here in Austin, Texas. So I would think so. I think there's certain ways that you could protect your grid system from this too. A lot of times you can even just put it below ground, I would think. But it is certainly possible. And not only, in different areas north of us, there's also a southern lights, if you will.
Really?
So the northern lights is a nickname for the aurora borealis. It's Latin in root. Aurora is Latin for goddess of dawn. Borealis is Latin for comes from the north. So goddess of dawn comes from the north. Aurora borealis. In the southern hemisphere, it's aurora australis. Aurora, goddess of dawn, australis from the south. So you do technically have two different lights displays, if you will, because those electrons, those charged particles are coming at both poles.
From the top to the bottom of the earth.
Yeah, and I think the northern lights gets a little bit more love because, just looking at a globe, there's a bigger population north of the equator in the northern hemisphere. And Antarctica, not quite as populated, even compared to, the Arctic up north. So it is a dual pole thing. We've got them at both poles, but the northern lights obviously is where our attention is because not only did we see that last night? But if you remember, we saw this last year too.
Yes,
remember in the
I
spring,
do remember talking about
we
that.
saw this, and there's a reason for that as well. And I know this looks really icky if you're not a science or math lover, but let me just simplify this for you. Our sun works on a solar cycle. It's about an 11-year solar cycle, and they go through active phases and maybe not as active phases within that 11-year cycle. So that graph kind of shows you there, if you look on the y-axis, the sunspot numbers, and that's important because astronomers, meteorologists, scientists will look at the number of sunspots on the sun, and the more sunspots we have, the more active we are in the solar cycle. Right now, we are at our peak of the solar cycle. We call it the solar maxima, the peak activity of the sun. And that can mean more sunspot. It can mean more solar flares. It can mean more of those coronal mass ejections. Those are those big ones that sometimes you see on TV. It's like this, almost looks like if you're like popping a pimple, all this stuff comes out of the side of the sun. I know, but you get the visual, right? You know what I'm talking about, where you see this big ejection from the side of the sun. Those coronal mass ejections, the sunspots, and the solar flares all become more frequent and increase in the number of those events during a solar maxima. We're in that right now. We are in that solar maxima. So it makes sense that we are seeing stronger geomagnetic storms right now, that we saw one of these last year too. And it really maybe doesn't sound familiar to a lot of people, because right now we're in that part of the solar cycle where things are getting very active, and it is expected, as you can see, to come back down again.
Yeah, and I think that a lot of people were confused last night to see the sky look so beautiful. And when they started to hear, oh, it's the Northern Lights, a lot of people were like questioning why.
Right.
So we touched a little bit on why they happen and why we got to see them here in Central Texas. But are we going to see them again?
You know, it's interesting because there is a potential that we see a faint aurora later on tonight as well.
Again?
So I'll put this back up just so you kind of know what we're looking at here. It is possible that, we still kind of see all those charged particles still coming around the magnetic field and into the poles, and we see that again around sunset tonight. So that's the thing. There are some forecasts that I'm looking at that say it maybe could be stronger tonight than what we had last night, but I don't want to promise you that. But in order to even have the opportunity to see the Northern Lights, what you want to do is, one, look north, obviously, right? These are the Northern Lights. They're coming in from the north. Look north. Two, this would occur just after sunset. So think, early evening twilight. Three, if you have a camera, an iPhone, you want to open up your camera and put it on that long exposure setting. A lot of the times the iPhones nowadays
Already
have this
have
built
on.
in.
Yeah.
Has it built in. Or sometimes if you have like live mode, live mode, it keeps that shutter open for a little while. Try that. Live mode, long exposure. And you want to get away from as much city light pollution as possible. And that, I think, is sometimes the toughest thing, because unless you're out in some of the rural areas, hill country, right along the lakeside, we fight a lot of light pollution here in the city of Austin and some of those bigger cities around Central Texas. So away from lights, north, after sunset, have your camera open. Hopefully we'll get another glimpse tonight.
And will it be the same kind of pink hue that we saw last night?
It should be, yeah, because we're so far south, I would be shocked if we get anything like the blues, right? Maybe
or the
a little
ribbons,
green.
the
I'm
greens.
thinking, more pinkish, more of those reds. But we could be surprised, and it's something that I get frustrated with because there's not a lot of time to give people heads up, and this is on the top of so many people's bucket list, to be able to see the Northern Lights and say you've seen the Northern Lights. I wish I could tell you, next Tuesday, we're going to get a great glimpse of the Northern Lights here in Central Texas. I cannot do that yet. I mean, these are ejections of the sun moving our direction at millions of miles per hour, speed of light, interacting with the atmosphere and giving us those ribbons of color in the sky. So there's just not that kind of science, not that kind of forecasting yet, where we can predict days in advance of a geomagnetic storm to tell you where to go to see it. So, it is a little bit of a bummer in that perspective, because I did see on social media, like, I wish they would have given us a heads up.
Yeah.
Like, I wish I would have gotten a heads up.
I know. People think that the sun texts you, hey, I'm going to have a Northern Light show today.
Exactly. So that is a little bit of a bummer. We also talked online this morning about, or on on air this morning about climate change. Does climate change have any sort of impact on the Northern Lights? The number of Northern Lights events, no. Climate change is an Earth problem, right? Mm-hmm. The sun, not dealing with climate change. That is our climate here on Earth. So the sun is still going to send out these plumes of electrons, these solar flares and such. What happens with climate change is if as a whole, our Earth is getting warmer, the atmosphere is getting warmer, warmer air holds more water. We know that. Physics tells us that. Warmer air, more water, more clouds. Yes. And that drops our visibility sometimes. So you could have a phenomenal Northern Lights event happening up in the upper atmosphere, but if you're sucked in with a blanket of clouds and fog, you're never going to see it. So that would be the only kind of correlation that we would watch for as scientists would be if our climate is changing, we're seeing more moisture, we're seeing warmer temperatures, and we're seeing more clouds at night, then unfortunately that would reduce our visibility of seeing such a, fantastic display of color.
And that goes for every area on Earth where you can see the Northern Lights. I had my sister-in-law recently traveled to Iceland to see the Northern Lights, and she said that it was so hard to see with her eyes, she had to look through her phone.
Yeah, and most of the time, especially when you're south of the Arctic Circle, you're going to have to do that. It is very faint. These colors that you see, it's not like you walk outside and you see a bright pink sky like the sunrise. It's very different from that. A lot of the times it's a picture with maybe a little bit more high contrast and a filter, but it is what it is. It's still the Northern Lights. It's still these electrically charged particles colliding with our atmospheric gases to create such beautiful colors.
And this is what it looked like in Texas last night. So like Kristen said, the sky is pretty much covered with that beautiful color hue.
Yeah.
And then you see some stars here and there, but not so much the ribbons that we can see in the north.
Yeah. So, I still think it's fantastic. I would still check tonight, especially if you're a weather geek, space nerd, like this is an opportunity to really lean in later this evening. But this picture, I think encompasses what a lot of us likely see is, maybe I see a little bit of pink on the horizon there when I look north. But some of us are lucky enough for the sky to look like this.
Yeah, it just depends where you are, how much light is around you, and how good your camera is, right?
Exactly. Yeah, for sure. I mean, some of those like gigantic telescopes with the fantastic lens. I mean, it's just spectacular what you guys can capture.
And if anyone is interested in learning more about the background that we talked about here on our stream, to the Northern Lights, we have that article on our website that Kristen published with all these pretty graphics.
Yeah, absolutely. We talked about this on air. I thought it was so timely. You see there the downside, some of the disruptions we talked about with the signals of the radio and grid system and all that. So hopefully that answers a couple questions of the beautiful sight we saw last night.
And last night's was pink, so that means the nitrogen was below 60.
Yeah, and I think it was probably a mix of red too. I saw some photos of either, and that's the thing is we've got gases at different levels of our atmosphere, and so that kind of thing happens.
Awesome. Well, thank you for sharing all of this with us, Kristen. I know it's a big question for everyone today.
Yeah.
Before we go, I do want to mention to everyone about Friendsgiving. Can you give us a little rundown of what's going on?
Absolutely. Friendsgiving. So do you have a graphic?
I do not.
I'm glad because I don't want that evening team graphic on here. Let me go to my graphic because in case you missed it, morning team versus evening team. This is our annual November competition to see which news team can raise the most money for the Central Texas Food Bank. KXAN.com/Friendsgiving is how you can donate. So it gives you the option to donate to team mornings or team evenings. Both teams donating all their money to the Central Texas Food Bank. Right now, Team Evenings is ahead by a little bit, but this competition runs all the way up until the day before Thanksgiving. So we've got a couple weeks.
We've got some time to donate to morning team.
Exactly. Got some time to catch up. But the need right now is obviously very pressing, given everything that's going on with the shutdown and whatnot. And it's been a hard year for a lot of Central Texans. So above all, we want to make sure that no Central Texan is worried about, will I have food on the table come Thanksgiving? That's the ultimate goal here. And right now we're about 44% of our goal combined. So morning team, evening team combined, we're hoping to raise $150,000. We're 44% of the way there. We could sure use your help if you're watching. So that link, kxan.com/friendsgiving, is a good way to find that landing page.
Perfect. Thank you, Kristen. And if anyone finds the Northern Lights tonight, please send those photos to reportit@kxan.com.
Yes, ma'am. I got a couple school shout outs.
Oh,
We got time?
Yes, we do.
Okay. I want to mention this because this is actually something new for me. I've never done this before. Coach Amber, there on the left, she is at Carver Elementary with Georgetown ISD. She sent me an email and said, hey, I'm a PE coach. Weather affects our bodies, what we do outside. Can you come to my school and do a talk on weather and wellness? And I was like, yeah,
that's interesting.
Exactly. I'm like, she's got such a good point. And it was a really, really, I thought, neat talk because, like I said, it's something I haven't done before. I mean, we talk a little bit about this on air, sure, but it was a very pointed talk about how, what our body does with cold exposure. We like to be that 98-degree temperature inside. And when it's cold outside and we're losing heat faster than our body's able to keep up with and our body temperature starts to drop, these are the signs to look for. We talk about hypothermia, in the shivering and your body working overtime trying to get the heat and the blood around. Same thing with heat exposure. We talked about that. What are the signs of heat stroke, heat-related illnesses? We talked about weather safety, what happens when you get struck by lightning, all these different things. And it was a great conversation, I think, with the fifth graders, specifically talking more about how weather affects our body and less of like the TV side of things of here's what a green screen looks like. That we didn't do that, and I really enjoyed it. So thank you so much to Carver Elementary. This is Regents School of Austin. Talked with their fifth graders about weather and weather safety last week, and they had some phenomenal questions for me too. One of the questions that I rarely get, and I appreciate when I do, is one of the gals asked, how do we know what the weather's going to be like next season or, a couple months from now, talking more climate and not just the 70 forecast.
Yeah.
So I love it. So
that's your favorite topic.
Yeah, exactly. A little bit about La Nina and some of the different things we look for in the ocean that can dictate where our jet stream or our storm track goes. So that was great. Had another visit up in Rancho Siena Elementary. This is Liberty Hill ISD. Talked with their first graders, the little bitties, earlier this week. This is actually the third time that I believe I've been out there talking to their first graders. And it's always so interesting because if you've ever been out there, first of all, it's a gorgeous school. Liberty Hill ISD, Georgetown address, from their parking lot, you can see the Leander Water Tower.
What?
So it's every single time I go up there, I'm like,
where am I?
I have no idea where. Yeah, because it's important. We talk about, weather where we live. I'm like, I don't even know where I am right now. But yeah, Liberty Hill ISD, Georgetown address, Leander Water Tower right there.
That's so funny.
But it, like I said, gorgeous school. I love being up there talking to their first graders every year. And then lastly, yesterday had Round Rock Christian Academy in studio this time. This is their fifth grade. They got 3 classes there. Played around the green screen, tried to figure that out, how we point to the numbers, how we know what's behind us. Sat on the news desk, did some talking there. A weather lesson, of course. So it was a great time.
That is so sweet. And that first topic that teacher shared with you, I think that's something that all students or all PE classes should put on their radar, because when you're playing outside for PE or recess and a tornado swings through, you got to know what to do, right?
For sure. And, it's something that got my brain going, okay, maybe we can do more Kristen's Classroom episodes on this. But yeah, really getting out the idea of, we always say don't go outside when it's cold. Well, why? What actually happens? What happens to our body when we're outside and it's 105 degrees and all of a sudden we stop sweating? Why do we stop sweating? So we answered those questions. And I told the students too, it's always going to be easier to see in someone else hypothermia, hyperthermia, heat-related illnesses than you are going to be able to see in yourself, because our body's fighting. When our body temperature is not where it should be, we're sweating, our pulse is going crazy, maybe
trying to make up
or dizzy.
Everything.
So you're going to have a harder time figuring out, something's wrong, because your brain's not quite thinking straight. But if you're looking at someone else and they're shaking and they're kind of going in and out and they're dizzy, you're going to know, right, whoa, something's wrong. You'll be able to identify quicker some of those heat-related symptoms or cold-related symptoms. And so that's what I kind of focused on in this talk was, hey, if you're outside and your friend's not wearing a proper jacket, or if, they're not wearing the proper mittens and shoes and stuff, and they start showing these signs, you need to get a teacher immediately. One of those kind of things. So it was a great talk, I thought. And so hopefully they learned a little something, right? Yeah. Accidentally.
Hopefully they're just that much safer when we get into the winter season.
I mean, that's the whole point of what I do in these weather talks, going to schools, having them come here, is just kind of plant the seed, right? You plant the seed of, if you are ever in this position, I want them to think, okay, one time that weather lady said if this happens, that's what I want you to do, right? You plant the seed now so that way when they grow up and become full functioning human beings in society like the rest of us,
they know what to do.
They know what to do. It makes my life easier as a communicator and, during inclement and dangerous weather when they already know what to do and I'm not having to teach them.
Yeah, that's the best part.
Yeah.
That's the goal. Kristen, thanks so much for sharing all these fun topics with us. It was a great show, and we'll see you next week.
Sounds good.